Welcome. Today, we're tackling a topic that literally runs our entire world, from your morning alarm to international business deals. We're talking about global time. It's a huge puzzle that stretches across the whole planet. So let's just dive right in.
You've probably had this thought, right? Maybe you're watching a live event from another country, or you're trying to call a friend across the ocean. How on earth can it be 2 different days at the exact same time? Well, that is the big problem our global time system was created to solve.
So, how do you fix it? Well, the solution is actually pretty elegant and, really simple in theory. Instead of having just one time for the whole planet, which would be a mess, right? Noon here would be midnight somewhere else. We just slice up the world into manageable, logical pieces.
And what's the magic number? It's 24, of course. There are 24 hours in a day, so the Earth is split into 24 main time zones. And in a perfect world, each one of those zones is a 1-hour jump as you travel around the globe.
And what's so cool is that the math behind this is super straightforward. The Earth, as you know, is a 360-degree sphere, and it spins around once every 24 hours. So you just divide 360 by 24, and you get 15 degrees of longitude for every single hour. It's a system that's literally built on the way our planet moves.
Okay, so having 24 zones is a great start, but it's not enough. For a system like this to actually work, everybody has to agree on a starting point, right? A single, universal reference that all the other zones can be measured against. And that's where the world's official clock comes into play.
And that standard is called Coordinated Universal Time, or as you'll see it, UTC. You can think of it as the master clock for the entire planet. It is the official 0 point. It's the baseline. All other time zones are just a plus or a minus from this one single point, which is based on the prime meridian that runs through Greenwich in London.
Now, you've almost certainly heard of Greenwich Mean Time, or GMT. A lot of people use it and UTC like they're the same thing, but there's a really crucial difference. GMT was based on the Earth's rotation, which, it turns out, isn't perfectly steady. It has these tiny little wobbles. UTC is the modern upgrade. It's hyper-precise because it's based on atomic clocks, which are incredibly stable. So the main thing to remember is that UTC gives us that rock-solid standard our modern digital world absolutely needs.
So we've got this nice, clean mathematical system with 24 1-hour slices. Sounds simple, doesn't it? Well, this is where things get really, really fascinating, because human beings get involved. Politics, geography, just plain convenience, and they add some pretty wild wrinkles to the whole thing.
And these examples show it perfectly. That 1-hour rule, it's really more of a strong suggestion. Take a look at India. It's 5.5 hours ahead of UTC. Or Iran, which sits at a 3.5-hour offset. And then you've got Nepal, which is on a 1/4 hour. It's UTC plus 5:45. These are all unique choices made by countries that bend those global rules.
And then we get to the seasonal wrinkle, the one that messes with all of our sleep schedules, daylight saving time. You know the drill, spring forward, fall back, all to get a little more sunlight in the evening. But not every country does it. India, for instance, doesn't bother with DST, so their time stays the same all year long.
Okay, so we figured out the 0 point, the prime meridian in Greenwich. But what about the other side of the world? What happens at that 180-degree line, on the exact opposite side of the planet? This is where things get a little bit mind-bending, because this line is where the day itself changes.
This imaginary line is called the International Date Line. Let's make it simple. If you cross that line heading east, say flying from Asia to the US, you actually go back in time a full day. You subtract a day. It's yesterday again. But if you're traveling west from the US towards Asia, you jump forward. You add a whole day. All right, now that we've got all the pieces, the zones, the offsets, the date line, let's put it all together. Let's see how this works in a single moment across the globe.
So, let's take a look at this chart. Imagine it's lunchtime, 12 noon in London. That's our 0 point, UTC. At that very same instant, it's still early morning in New York, only 7 a.m. because they're 5 hours behind. Meanwhile, in Tokyo, they're winding down their day. It's already 9 p.m., 9 hours ahead. And in Sydney, it's even later, 10 p.m. See? One moment in time, 4 totally different experiences of the day. That's the whole system in action.
So why did we go to all this trouble to create this really complicated global system? I mean, it's easy to forget it's even there. But before we had this standard, it was absolute chaos. Every city just set its own time by the sun, which made things like train schedules a total nightmare. This system brought order and, frankly,
Our modern world could not run without it. When you get right down to it, time zones are the invisible engine of our globalized world. They're what allow the stock market in Tokyo to close just as things are heating up in London. They let air traffic controllers manage thousands of flights crisscrossing the globe safely. It's this quiet, brilliant piece of global cooperation that affects everything from military planning to making sure the GPS on your phone actually works.
And that brings us to a final really interesting thought. This whole system was designed for a physical world, right? For ships and trains. But we now live in an instant digital world. So the question to leave you with is this. Is a system based on where the sun is in the sky still the best way to organize time? For a species that now pretty much operates on a global scale 24/7?